Hello everyone! Today I'm going to talk about time complexity and algorithm type cases. This is my first video and I'm going to talk about the basics of an algorithm. So I'm going to start by talking about concept of upper bound and lower bound. O, the big O, yeah, is the most used term in time complexity. It refers to the upper bound on runtime. Everywhere you go, when people talk about time complexity, you will hear something like, so what's the big O? Or someone will tell you, they will take O of log n. And so I'm going to talk about those specifically later, but here's the question. So what is the definition of an upper bound? Upper bound simply indicates less than or equal to relationship. So the upper bound sets the maximum value of an algorithm's running time. So it's actually the maximum value. That means when you code out something and you have a program, you're assuming that the program won't take longer than that. The number that you give, the O of some time. Big omega, on the other hand, is the lower bound. Lower bound is greater than or equal to. So lower bound indicates that the running time of an algorithm cannot be faster than the suggested time. It is not entirely correct to say that the big omega is the direct inverse of big O. However, based on how they are being called, upper bound and lower bound, you can simply assume that they are direct opposite of each other. This is not necessarily true because sometimes both upper bound and lower bound can be the same. And here comes the case. Interestingly, there is an occasion where upper bound and lower bound are exactly the same. This is called big theta. This happens when both maximum and minimum value are the same. So I think this is the correct time to talk about or give you guys an example. So let's say humans cannot live longer than 200 years with our current technology. Assuming that X refers to the human age, the statement X is less than or equal to 200 is true because humans cannot live longer than 200 years. This indicates that the upper bound is 200. Lower bound, on the other hand, would be something like, well, when you're first born, you either start with 0 or 1 depending on the country and location of birth. So let's just say when a baby is born, a baby is 0 years old. Then the lower bound is obviously that 0 because there is no concept of negative age in our world, if I'm correct. If I'm wrong, please correct me. The cases. Now I'm going to talk about the cases. Best case is obviously the best possible running time you can get from an algorithm. Say you are building a fancy robot that will do every annoying task for you that you have to do otherwise. Some experts say it will take 1 year at the fastest and 3 months if things go really, really well. Here, the best case is 3 months and the worst case is 1 year. Expected case, it should be somewhere in between those two numbers. So you may assume it's going to be 7 months and half, which seems to be the average of those two numbers. But beware, the expected case could be actually different because we actually do not know the average time it takes to build a robot. If that robot developers say the average time usually takes about 6 months, then the expected case is going to be 6 months. Interestingly, the expected case and the worst case are usually the same for the algorithms that we build. In the next video, I am going to talk about space complexity and some more. Thanks for watching my video. and see you guys in the next video.